Hi, everyone. Thank you for joining us in our second episode of Courtside View. My name is Iman Bhattacharya, and my colleague Theodore Johnson, is here to talk about all things data science. In the first episode of data science, which is already there, we talked about building a simple RAG pipeline with Neo4j and biomedical KHD. In today's episode, we are going to talk about what are the ontologies and why they are important. To talk about that, we have our senior data scientist, Ted Johnson, and my name is again Iman Bhattacharya, your host, Senior Global Product Marketing Manager from Kaizen. Ted, welcome to our second episode. And if you want to just take this ahead and start with a little bit about what are the ontologies and what are the importance and why they are useful.
Yeah, thanks, Aman. So I thought it would be nice today to take a step back from GraphRag and think more about, what are graphs in general, and especially what is an ontology, right? And to do that, I'm going to take a favorite quote of data scientists and statisticians that all models are wrong, but some are useful. And when we talk about that in terms of ontologies, what we're doing is we're using language and maybe some tooling and database tooling to build models about, the knowledge domain around a special topic, right? And when we do that, our models are never perfect, but they help us develop a common understanding of that topic, which helps us solve problems, and it also helps us communicate with each other, about that topic area. So to do that, I'm going to really just dive deep into this idea of ontologies.
That's awesome. So, can you talk to us a little bit about what do you mean when we talk about ontology in data sciences and some of the definitions and representations?
Yeah, so ontology is a school of philosophy, and in some ways it's related to ideas like epistemology, the study of truth, and ontology is really trying to understanding the structure of knowledge, right? And to do that, we take kind of several core concepts and we build out from there. So we start by defining a domain of discourse. So that is kind of the same idea as the universe of discourse in philosophy, saying that we're going to choose a topic area that we're describing, and things are going to be inside that topic area that we want to discuss. And anything outside of that topic area, we're going to say, we can't define them. They're not really interesting in this area we're talking about right now. And importantly, there's this idea of representation, and that's how we're going to choose to represent the things in our domain. You might think about that as like if we're discussing music, you might think about the sheet music, that defines a song. That might be, one representation of music. Or you might think about the sounds. That's another representation. So we're going to define in this domain of discourse, what are the things? How are we going to talk about them? Right? And then we're going to talk, because we talked about these things, a system of formal naming. How are we going to talk to each other about them and understand, what we're talking about? And when we use words, we're going to understand each other because we're staying kind of in a constrained and well-defined area, which of course leads us to this idea of definitions. So when we use a formal name, we always know what we're talking about because we're constraining ourselves to this structured definition in our space. And then this idea of properties. So, once we've described these things in our space, there's certain things that belong to them, like my height. My height is a property, it doesn't exist if I'm not here. My height can't get left behind and be standing in the room, right? So it's something that only exists in the concept of my being, right? And then relationships. Once we really get into ontologies, what we really want to talk about isn't just the things themselves in isolation. We want to talk about how ideas connect to each other. And with that, I thought I might dive back into the idea of the domain of discourse and kind of expand on that a little bit, if that's all right with you.
Yeah, let's go ahead and dive deeper.
Yeah. So when we talk about a domain of discourse, we might decide that we here at Kaizen are interested in human biology and human disease. And we're interested in the tools we use to measure that. So we might, include in ontology the ideas of, what is a human, what defines a disease, what defines a pathogen. We might also want to define, ideas like, what is a gene sequencer, what is PCR? But we might not be interested in discussing ideas like space travel or video games or office supplies. So when we design our ontology, we're going to want to think about, what areas do we need to be able to discuss, with absolute clarity? And then what areas, can we leave out? What saves us that effort by leaving certain things out of our domain of discourse, right? So that's kind of the key foundational part of ontology is, what items in our, real world are we going to try to model, and what do we need to capture in here to do that accurately and have, useful conversations. And then once we do that, we have to decide, what counts in our space as a representation. So, here's this idea that connects all the way back to Plato, and this idea of ideal forms, right? So we might want to be discussing shapes in my pretend ontology here, and we might be interested in, circles, right? And we might say that what we're trying to talk about is like all the things that belong to this idea of, a perfect circle or have the properties, we might associate with circleness, right? And we might decide to represent that in different ways. We might use words, the word circle. We might use equations, maybe describe the circumference of a circle. We might draw them, and we might draw them, with a computer. We might make a crude, swoop with our mouse and try to just draw an idea. And we might say, that counts as a circle, for the purposes of our conversation, right? And that gets into this idea of representation. How are we going to take these ideas and capture them in a way that enables us to talk about them? And with that, we might say that, for the purpose of our ontology, we're going to define it, right? We want to lock in a definition, and we might say that this circle is a shape that closes an area that has an outside edge, and its circumference needs to closely approximate, 2 pi r, right? And so for my early examples, we might say like, circle covers that. That's what the word circle means. And the equation covers that, in some ways it is the definition. And maybe a computer rendering is sufficient, but maybe my crudely drawn swoop, maybe it doesn't fully enclose an area, maybe it had a right angle in it. That wasn't good enough a representation for this ontology. So we might move that somewhere else. Maybe we still need to describe it, but it fits better in another section. So using our definitions, we've kind of constrained this space, and now we kind of have this idea of what things count for the purposes of our ontology, for describing the things we need to describe. And that you might take the idea of formal naming. And this gets, in some ways really complicated. We might say for our purposes that words in English are sufficient for formal names, and we might just choose, circle attaches to this definition. It means, anything with a circumference that encloses an area that roughly fits this idea of 2 pi r. But, we might be working across international boundaries. We might need to include, various names. We maybe, for our ontology, need to be able to translate this idea, of being a circle, beyond the confines of one language. And so a lot of times, ontologies have this idea that we say, we're going to use an identifier, and that's going to capture this definition, of being a circle. And that will allow us to change out, other representations, say, of the word for French or Spanish or German or, Japanese, any language that we need to use to capture this idea effectively in our communications, right? And that's something you'll see a lot. And when we show earlier, some common examples of ontologies, Disjonet, Go, ensemble, they all use symbols that represent our objects instead of necessarily using the direct word. Because as we all know, when different groups of people are naming an item, we tend to choose different names. So this gives us a more comfortable way to discuss, these items and make sure that no matter who the speaker is, we can always tie back to a unique identifier that lets us, in terms of our database, keep track of all of our discussions, right? And that lands us back on this idea of properties. Once we've defined a circle and we might have examples of a circle, those could be thought of as instances of a class, where the class would be all the things that fit our definition of circle. And then we might have a specific circle, and that could have properties like, this one has, a radius of 2 centimeters, and, it's got an area of, 4 pi centimeters. So properties, they belong to that instance. They are specific to its existence. And if that circle goes away, those ideas about it really can't stand on their own. They belong to it. And that's important in ontologies. We want to define down from this realm of general concepts, what's the perfect idea of a circle. But really we want to get down into the specifics. We might need to specifically talk about individual circles in our ontology. Similarly, in a more real example, we might need to talk about a specific instance of a protein and what mutations that instance has and what effect that has on biology. And while it's still important to know generally, what class of proteins does it belong to, what relative proteins would be similar to it, we want to get down also to those specific properties, and that's how we do it in ontology.
Thank you. So what we learned is domain of discourse, representation, formal naming, definition, properties, and relationship. Ted, can you tell us a little bit about why use an ontology then? What is it that we use for?
Yeah. So there's a lot of utility to building an ontology, and I've shared several examples, and there's numerous different ontologies in biology. I think a lot of our users have probably encountered Go, and they've usually encountered dysgenet to describe diseases. And what we're all trying to do when we get into these spaces is have a useful conversation about disease areas, right? We want to be able to talk about, if we want to cure a disease, we have to agree on, what is the disease, right? If somebody has that disease, we have to agree on, what symptoms does it contain, what measurements do we take to diagnose it? And it pays in that space to have a common language that describes all of these things. And so the first part of that is you build an ontology for collaboration, that we all agree on the words we're going to use, the measurements we're going to take, and we agree to organize them a certain way so we all understand each other. Really attached to that idea is this idea of interpretability, right? If we have a defined ontology and I complete some work in a space and I document all of it, according to our formal definitions and the formal relationship between entities, and I hand that off to another employee or another user of that ontology, they can figure out what I was working on and what I was talking about, and they don't necessarily have to find, my individual efforts or how I personally thought about these different words. They can go back to those formal rules and understand based on the ontology we were using, how I was talking about ideas. And that kind of even deeper goes to this idea of decision capture. So when we're capturing all these ideas in an ontology, as an organization, we're also capturing how we think about that domain. How do we organize things into groups? Do we think that items can belong to more than one group? Can you have, properties of, 2 disease categories, for instance? Can you be, an irritation of skin and also an autoimmune disease? And so that helps us understand as a community, how we think kind of different broad categories of things relate to each other. And then when we decide these things are related, it helps us, store that decision for the future. So when new users come online, when new students are picking up this topic, they can again go back to this idea of formal definitions of terms and relationships to jump in. And they don't necessarily have to rely on the individual understanding of a mentor to kind of get into that space. And then finally, the big topic, of the year is this idea of powering AI and machine learning. We really want to be able to use machines to talk about ideas and to reason through problems. And, the the tremendous challenge throughout a lot of computing's history is that humans are good at being flexible in our understanding. We can handle more than one definition. We can kind of self-assemble our own, personal understanding of how items are related. But computers, do better with more structure. And so when we're laying down these ontologies, we're helping ourselves, we're helping, future generations of humans, but we're also helping empower these AI tools, tools that can use these underlying structures to help, that machine understand a domain and start, doing reasoning over this. And there's tools built in these areas that really leverage this structure to help machines make choices and work. So, this is an example where we're helping ourselves, we're helping humans, but we're also laying down a logical framework that actually helps translate how humans think into how machines can compute. And that turns out to be a huge advantage.
That's great. Thanks for explaining in 4 key points why use an ontology for collaboration, interpretability, decision capture, and the recent topics powering AI and machine learning. Why don't you give us an example of that?
So to start with an example, I want to reference Gene Ontology. One, because it's an example that a lot of biologists are going to be familiar with. They've probably used it themselves. And two, because it is a well-structured example of an ontology. So when you look on Gene Ontologies, you're going to actually see 3 different ontologies, and they've designed that so they have kind of 3 separate top-level concepts: the Go biological process, the Go molecular function, and the Go cellular component. And in each of those trees up at the top level, you actually have, the tree itself defined. So that idea of being a Go cellular or a Go biological process, that's captured at the top of the tree. And then at each layer, you go down to the children of that, idea, that idea of being a Go biological process, and then you might capture cellular processes. And below that, you might capture this idea of a metabolic process. And then as you go down, you get into these, more and more specific ideas that capture a more specific example of this, important biology. In their example, they go down to hexose biosynthetic processes. So processes that develop a single kind of 6-sugar molecule or a 6-carbon molecule. And this is an idea that you're taking these general processes, these general ideas, and you're defining that space, and then you're subdividing it into smaller and smaller categories until we get to these ideas that are very specific to maybe one or a few molecules that contribute to them. And that allows us to talk about everything from kind of a general space to the very specific activities of 1 or 2 molecules, which is hugely useful. And if we jump down to the next part of their example, they define everything with these required components. So everything in Go has a Go ID, right? And they call it the Go accession number. And that is going back to this idea of our defined vocabulary, right? So that Go ID is really the way we're referencing an entity. That's our representation in this space. And every representation, every Go ID has a defined name. In this case, we're showing an example of fumarate reductase activity. And it belongs to a domain of discourse. So this example we pulled out of the molecular function tree. So we know kind of what space we're defining objects in. And every one of them then has a definition. So when we talk about this fumarate reductase activity, what specifically does that mean? And then importantly, we have its, relationships. So we have these participant molecules that join in this process, right? So that gives us that context. And then built into Go is then those parent and child relationships as well. So if we need to go maybe into the more general category of reductase activity, that connection exists in this ontology. And again, that gives us useful ways to understand molecules. Maybe, for instance, we are talking about, NAD. and we need to know that it has this fumarate reductase activity, but maybe that's too specific for us. We're trying to group this with other molecules, so we might travel up the tree and group items together as we go and say that we're going to talk about all molecules with reductase activity, right? And this becomes this really useful tool to do that. You can start using graph languages like RDF, like Sparkle to define this, and kind of to facilitate doing this grouping. You can use tools like Neo4j, where you've uploaded your molecules of interest and these ontologies, and you can start using those query tools to do these kind of interesting groupings and problem solving. So this is where this becomes a really useful tool. Not only have we defined this space where we all know what we're talking about when we choose a term from here, and if we don't know what we're talking about, we can go to an objective reference material and learn, what everyone else is saying when they're using these terms. And then we can start using this powerful tooling layered on top of it to start actually doing some deeper learning and understanding.
That's great. That's a great example. And coming back to home, I know in Kaizen we maintain an internal knowledge base. So can you tell a little bit about that and also how these are useful to the users, how these tools are useful to the users?
Absolutely. Yeah, so when we think about ontologies, you start by defining a domain of discourse, right? And we choose maybe a specific area, like Go chose Go biological processes and molecular functions and cellular components. And that can be really satisfying within those domain areas. But then you need to work farther out. You need to name genes and you need to understand what they do. And then you want to kind of start translating between these different domains. So at QIAGEN, we have our team of expert curators, and we have our ontologists who have built out our own internal ontology and also use that to start making connections between these different open ontologies, right? Kind of a Rosetta Stone, if you will, that connects these ideas of different ways we can discuss biological topics. And we start attaching them to tools. So I think a lot of our users are going to be aware of IPA, and that leverages a variety both of our internal knowledge and these extensions into different domains of ontology to add these tools that allow you to upload genetic data and then start building biological networks and understanding biological networks. Similarly, we have products like BKB, and these let users start exploring kind of how do we understand these different domains? How can you delve into those connections and start, understanding how maybe the topics that are interesting to you are connected across these different ideas to other proteins, to other disease areas. You can use that to do hypothesis generation and a variety of really interesting tasks. So really at QIAGEN, we bring this expertise in ontology and this kind of expertise in building knowledge bases, and we help you leverage that to understand biology.
That's awesome. So, what I learned today is that ontologies are structured frameworks that defines concept, categories, and their relationship with a specific domain. And ontologies support effective communications by standardizing terminology, ensuring a shared understanding. And there goes our episode 2 of Courtside View. Thank you, Ted. If you have any questions, get back to us. Let us know in the comment sections or reach out to us in our social media. We'll come back to you in the episode 3 with another topic. Keep watching Courtside View. Thank you.
Thank you.
Sample to insight.